All right, so the fun continues. We're going to look at defining a plane in 3D space with some vectors. So a plane in 3D space can be defined using two vectors, a position vector A of a point A that's on the plane, and a vector that is perpendicular to the plane. And so this is our vector equation of the that defines a plane. And let's just sort of understand where this comes from. So first thing we just recognize that again we're in the 3D viewer here, we're sort of in three-dimensional space. We've got our X, Y, and Z axes. What we're going to do is we're going to put in a plane, okay? And we're going to think about how we could define this plane in space. So what we're going to do is we're going to put some point A on the plane. Now, it's a bit hard, but hopefully you can see that that point A is in fact on the plane. And then what we're going to do is we're going to put a vector. We're going to call that vector A. Pretty straightforward. That's from the origin to that point A on the plane. So hopefully that's all good for now. And then what we're also going to do is we're going to put another point P that is also on the plane. As you can see, that point P is on the plane. And what we're going to do is we're also going to put another vector. We're going to call this vector R that goes from the origin to the point P. So that looks like that. Okay, what we're going to do now is we're going to do some vector subtraction. So if we put the vector between the points A and the points P, that would be vector R minus vector A. And I encourage you to get out a piece of paper or whatever you need to do to sort of make sure you understand that. But that vector R minus vector A will connect the points A and P. And I think you would agree, because A and P are on the plane, that vector itself will also be on the plane. So we get the situation going on here. Now what we can say is this. We can also put a vector sort of perpendicular to the plane. We'll call that vector N. So that vector N, you can see, is 90 degrees to the plane itself. So that's pointing out of the page, right? There you go. You can see it from behind as well. All right. And so what we're going to do now is we're going to say the following. We're going to say that vector R minus vector A is perpendicular to vector N. So we would say that the dot product between them is zero. And I encourage you to watch some of the other videos about the dot product to make sure you understand that. But what we can then do from there is that we can expand that out. So we're going to get vector R multiplied by vector N minus vector A multiplied by vector N, and then add vector A, vector N to the other side, just using some simple algebra there. And so then we can say to ourselves, all right, as long as we've got given some vector R that's on the plane, well, let's go back to the start. So a position vector A, so as long as we get given this position vector A and a vector perpendicular to the plane, then we can define that plane in space. Okay, so hopefully that sort of makes sense. And good luck with your studies. I'll talk to you soon.